All right, so 4.2, we decided to split up into two sections. So this is 4.2a, which is covering just parallel lines being cut by a transversal. In this section, we explore the different types of angle relationships that pop up when we do have parallel lines cut by a transversal. So for the first four, our directions are classify each pair of angles as alternate interior, alternate exterior, consecutive interior, or corresponding. Okay, so it's important to note that consecutive interior is the same thing as saying same side interior. Okay, so those two terms can be used interchangeably when we're referring to angle pairs. So let's look at number three. So number three, we're given angles 1 and 2, and we're asked to determine which of these four are they. Well, we can assume that these right here are parallel lines, which would make this diagonal line right here our transversal. Okay, so if it's going to be alternate interior or alternate exterior, the angle 1 and angle 2 would have to be on opposite sides of this diagonal line. So we know automatically that we can rule out alternate interior and alternate exterior. Okay, we know that angle 1 and angle 2, they're both inside the parallel lines here, so we know they're going to be interior. So right now we have same side interior, so let's just check and make sure that they're not corresponding. So corresponding angles would have to be angles that would be in the same position. Okay, so if we look at this group of four right here, angle 1 is in the bottom right. And we look down here, this group of four. And what I mean when I say the group of four is the two lines are intersecting and they're creating four angles. 1, 2, 3, and 4. So when I say the group of four, I'm just talking about that spot of intersection that has four angles. So in this group of four, angle 1 is in the bottom right. In this group of four, angle 2 is in the top right. So these angles aren't going to be considered corresponding. So the only one that's left is they must be consecutive interior or same side interior. Let's look at number 4. So number 4, right off the bat, if we're determining if it's alternate or same side. So we've got these two lines. They seem to be going in the same direction, so we can assume these are our parallel lines. And then we've got this line right here. It's going to be my transversal. So if these things are going to be considered alternate, I need to have one on one side of the transversal, the other on the other. So angle 1 is on the left side of the transversal. Angle 2 is on the right side. So it seems like these are going to be alternate something. Okay, so we know we can rule out consecutive interior. Okay, so angle 1 and angle 2, they are both outside of the parallel lines. So parallel lines being right here, they're both outside of the parallel lines. So that's going to tell me exterior. So right now I have alternate exterior, and that's exactly what it's going to be. All right, so on number 5, we need to, in this figure to the right, we need to name all the pairs of corresponding angles formed by the transversal T and the lines S and C. Okay, so we got our two lines here, S and C. They're being cut by this transversal T. So corresponding angles are going to be angles that have the same position or the corresponding position. Okay, so two ways we can think about this. As the transversal intersects each line, it creates four angles. Okay, so as T intersects with S, it creates angles 1, 2, 3, and 4. As T intersects with C, it creates angles 5, 6, 7, and 8. So one way to determine if two angles can be corresponding angles is if we look at the groups of four. Okay, so in this group of four, there's a top left, a top right, a bottom right, and a bottom left. So the angle that matches up in the position, so top left would match up with top left. So that means that 1 and 5 would be considered corresponding. 2 and 6 are both in the top right, so they'll be considered corresponding. 4 and 7 are in the bottom left, so they'll be considered corresponding. 3 and 8 in the bottom right, so they'll be considered corresponding. Another way to think about it is, let's say that you were to cut into this figure and slide line S until it lie right on top of line C. Well, then the angles that wind up lying right on top of one another would also be considered corresponding angles. So if we were to do that, we would still see 1 and 5, 2 and 6, 4 and 7, and 3 and 8.